Okay, so we are going to talk really briefly about special solutions within an inequality. So we've talked before about special solutions. That's when you get an answer that is either a true statement or a false statement when you no longer have a variable, which gives us an answer of all real numbers or no solutions, right? So we have those same things within inequalities, but it's done a little bit differently. So let's go ahead and just solve this out. I'm going to start with distributing my 2. So 2x plus 6. Bring down my same inequality symbol. Distribute this to 2x plus 4. Okay. Well, again, I'm always going to begin by moving my variables to one side. So I'm going to subtract 2x from both sides. Okay, so I've got 6 is greater than 4. Okay. Well, looking at my answer, it used to be that if we saw two different numbers here and here, we would just assume that it was no real solutions, right? Because there was no number where something equals something if those two numbers are different, right? But in this case, is this a true statement? Well, yes, 6 is greater than 4, right? So because it left us with a true statement, our answer is, just like before, all real numbers or all real solutions, right? Same thing. So the thing that's weird about inequalities is that when you get two different numbers here, that does not necessarily mean that it's automatically no solutions. Okay, you really have to look and see if it's true or false. In this case, it is true, so it is all real numbers. So let's do another one. Okay, again, we're going to start with the distributive property. 3 times x is 3x, 3 times 3 is 9. Bring the rest of it down. Oh, not an x. Sorry. It's supposed to be forcing. 4 plus 3x. Okay, so again, move my variables to one side by subtracting 3x from both sides. So 9 is less than 4. Okay, well, again, is 9 less than 4? Is that a true statement? Well, no, that is a false statement. 9 isn't less than 4. It's more than 4, right? So because it's false, our answer is no solutions. Okay, and remember, this only occurs when your variables disappear from both sides. Okay, people get really excited about no real numbers, no real solutions, and they just start slapping that as their answer when anything gets difficult. Just because a problem starts to look weird does not mean it's no real solutions or no numbers. Okay? All right, so y'all go ahead and try this one on your own. I'm going to suggest that you pause the video. I am going to work it out. Before I do that, though, I want to remind you that you're going to start with distribution, but you're going to be distributing a -4. Don't forget that. Okay? So go ahead, pause this now, work it out, and then play when you're ready to see the answer. Alrighty, so I'm going to go ahead and work this out. I'm going to bring 10x down. I'm going to distribute -4, right? So -4x minus 12. Hope you remembered that minus 12. Distribute the 3, so I've got 6x plus 24. Okay, I'm going to go ahead and combine like terms here before I ever move anything to a certain side. Ooh, sorry y'all, smart word problems. Okay, so 6x minus 12 is less than 6x plus 24. Well, again, let's go ahead and move our variables to one side. So I've got -12 is less than 24. Well, is -12 less than 24? Is that a true statement? Yes, that is a true statement. So our answer here would be all real numbers or all real solutions. Remember, these things all kind of mean the same. Okay, now before I move on, I do want to talk about what this means. Okay, and I didn't actually prep for this, so let me go ahead and clone this really fast. Okay, so when I say all real numbers or all real solutions, what that means, let me go ahead and jot that down. Our answer was all real numbers. That means that every single number in the world should work for x. So we're just going to go ahead and try this out. We're going to test ourselves. I'm going to go ahead and plug in a 2 everywhere I see my x. Okay, I'm going to put it in a different color so it's a little bit more obvious. Okay, so everywhere I have an x, I'm going to go ahead and just plug in a 2. Where did I get 2 from? I literally just picked it because it's an easy number to work with. Okay, you could plug in a 3, you could plug in a 4. That's the point of it being all the numbers, right? You could plug in 2, 4, 19, 3,000. Any number you want to should work when you plug it in. Okay, so let's go ahead and PEMDAS this out. 10 times 2 is 20 minus, go ahead and do my parentheses here. I'm right here. 2 times 2 is 4. 4 plus 8 is 12. Okay, so now I've got 20 minus 20. Hey, that worked out nicely. So 0 is less than 36. Well, is 0 less than 36? Yes, it is still a true statement. We will continue to get true statements no matter how many of these numbers we plug in. I could do this over and over and over. You could pick your favorite number in the world, plug it in, and it would work out to be a true statement at the end. This is a true statement, okay? Now, conversely, if we have a no real solutions, let me go back a little bit. This one is no solutions. Let's clone this page. So if we do a no solutions problem, that means no matter what I do, any number that I try to plug in, it is not going to work, okay? So let me rewrite the problem, okay, and pick a different number. I wish I had a student in the room right now that could just throw a random number at me. I'm going to do 12. I just picked 12. And I'm plugging it in everywhere I see my x's, okay? So again, because I already know, I solved it a second ago, because I know my answer is no solutions, no number that I plug in is going to be able to make this thing work out. Well, let's go ahead and test it. So let's PEMDAS. Always do multiplication first, right? Okay, 3 times 15 is 45. Over here, 4 plus 36 is 40. Well, is 45 less than 40? No, that is a false statement, right? That did not work. So my answer is still no solutions, right? So this is just kind of a way to test whatever answer you get. If you get all real numbers, then you better be able to plug any number in and have it work. If you get no solutions, there shouldn't be a number that you could ever plug in that would make it work. Okay, so let me know if you have any questions about that. Again, this is just to recap that if you get a problem where the variables cancel out, like we did here, where the 6x and 6x were both gone, you just need to test that bottom statement that you get, the very last thing you end up with, see if it's true or false, and that'll determine your answer. True means it's all real numbers, false means that there's no numbers.